In this video, we are going to revise questions from section C of Science Paper 2 for 2016 internal. Now, we have the first question here. Start the following sequences of reactions. So, these arrows represent the reactions in which these substances underwent to produce the next substance. So, the first substance was glucose, produced ethanol. Ethanol is an alcohol. Then ethanol produced ethene. Ethene produced polyethylene. Now let's look at the first question here. Roman number 1A. What name is given to the process by which glucose changes into ethanol? So we have been given a question. If we have glucose, if this is glucose, then if we make alcohol, which is ethanol, from glucose, what process can we use, or what name is given to that process where alcohol such as ethanol is formed from glucose? So this process is known as fermentation. Okay, so now we can move on to Roman number 2. Name the enzyme responsible for change in one above. What gas is produced during this process? So now, during this process, we need to know the enzyme. So the enzyme that is used during fermentation is zymase. And we know the function of the enzyme. The enzyme acts as a catalyst. So it is there to speed up the chemical reaction. This reaction is the breaking down of glucose into ethanol. Now, whenever we produce ethanol, the gas that is produced is carbon dioxide always. So here, we are going to have carbon dioxide. So that is the gas that is produced. Now, we can move on to question B. Name the process and the catalyst used when ethene changes into polyethylene. Now, polyethylene is a polymer. So how can we produce a polymer? So a polymer is produced whenever we mix two or more monomers. So if we have a monomer plus another monomer, maybe plus, we can say 3 plus another, the third one, monomer. So if we are to combine these smaller molecules here, what can we form? So we can form what we call a polymer. So polyethylene is an example of a polymer. Now from the word polyethylene, we can see that if we separate this word into two, we have the first party, poly, then the second party, ethene, indicates the monomer that was used. Now, here, we need to know what is this process where we add the 3 or 4 or 5 monomers to form a polymer. So, this is what we call addition polymerization. So addition polymerization. So that is the process of forming polyethylene. Then from there we have another question here where we are told to give the catalyst during addition polymerization. So the catalyst is Ziegler. So this is the catalyst that is used. Okay, so now we move on to question C. Draw the structure of polyethylene with 3 repeating units. So now this 3 is giving us the number of the monomers that we are going to use. Now maybe for us to understand this, so let's first begin by how these monomers must combine to form this polyethylene. So we have 3 monomers. Then we're saying if we add these three monomers, we are going to get a polymer. So it is a large molecule. Now the monomer, from the word polyethylene, the monomer are ethene. So you remove poly, then the remaining part represents the monomer. So here we are looking at ethene. So we are going to write these molecules, since we are told 3 repeating units. So if we add these 3, we are going to form, now you add poly plus the monomer, which is polyethylene. Then in terms of the chemical formula, the chemical formula for ethene is C2H4 plus another C2H4 plus another C2H4. Then for the formula for polyethylene, you just have to add the number of carbons together. So here we have 2 plus 2 plus 2. So this will give us 6 atoms of carbons. The other one, we add the atoms of hydrogen. So we can see that this will add up to 12. From there, we can now look at the structure. So ethene has a double bond. So this is how the structure is drawn, plus another ethene, then plus another ethene. Now after polymerization, you need to know that the double bond should break into single bonds. So here you just have to draw the single bonds only. So we can see that we have 1, 2, 3, 4, 5, 6. So we have maintained the 6 atoms of carbons. Then we have 12 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So whenever you're dealing with polymerization like this one, addition, there will be some bonds that will remain unbroken. So here we what this means is, if we want, we can add more of these monomers to these bonds. So that's what you do. You need to make sure that these 2 bonds must remain open. So the final answer that we wanted here, we just wanted the structure. So this is our final answer. But for us to find this final answer, these 3 units have helped us. Or if we want, we can also summarize this. We can just write C, then we can just write one structure for ethene, then we enclose it in the brackets. Then we can look at how many repeating units. So we have 3. So here we have any. So any indicates the number of repeating units or the number of monomers. So we put 3. So 3 means that we have 3 molecules of ethene. Then here, when drawing the structure, you do the same as we did with this one. So that is the point you need to know whenever you're dealing with addition, polymerization. So we can write the 2 structures. If we are taught to use the equation, we can write it by showing the 3 repeating units the way we did here, or we just put it in brackets, then we use the number of repeating units. So all in all, we are saying the final answer, we just wanted this structure here. Okay, so now we move on to question D. When polyethylene is burnt in excess air, 2 products are formed. Name the products. So when we look at a polymer burnt in excess air, we are looking at the complete combustion. So the product of an organic substance, when it is undergoing a complete combustion, the products are water and carbon dioxide. As long as it is excessive, you have carbon dioxide. So these are the two products that you need to have in mind. Then for question E, polyethylene is a non-biodegradable substance. Explain what is meant by the term non-biodegradable and state the effect of such polymers on the environment. So for non-biodegradable, we are looking at substances that cannot be broken down into like a simpler one, or maybe we can say substances that cannot decompose. Doesn't matter how long they stay on the environment, they can't decompose. So this also means that we are looking at the substances that even if the bacteria are present, their effect of decomposing them into maybe manure or other waste product, these substances cannot be broken, such as plastic. You can see no matter how long you've buried a plastic, you find that the plastic will remain like that, doesn't decompose. So that is an example of a non-biodegradable. So see, these are substances that cannot be broken down or decompose by naturally in the presence of bacteria or the decomposers. The decomposers, we have microorganisms like bacteria, or we can just say the fungi kingdom. So the fungi kingdom consists of the organism that can decompose a substance. Then the other question here, we have two questions in this one. They have also told to state the effect of such polymers on the environment. So they can cause water pollution. So if we allow these pollutants into water, we can have what we call water pollution. And sometimes if we try to burn some of these, we may also find it that we may cause what we call the global warming, or maybe we can say the air pollution. Okay, so now we move on to question 2. 1 measure of copper is copper pyrite, which is chemically known as copper iron sulfide. To extract copper from the ore is crushed, then undergoes flotation, and finally roasted in the air. The metal is then purified by electrolysis. Explain why the copper ore has to undergo flotation. So maybe let's try to have a picture. Let's say we have a tank. This is our tank here. Then in this particular tank, we have some oil, or we can say a certain detergent. So here I'm just trying to give you a picture of what happens whenever they're extracting copper. So in mines, so here we have let's say this is that is our copper ore. Now in this copper ore, there are substances like sand. We have sand. Then apart from sand, there is iron. Then also there is apart from iron, there is sulfur. Then also you'd find that there is the copper that we want. So whenever we look at the extraction of metal such as copper, we are looking at how can we separate the impurities from the pure metal, or how can we separate this pure copper metal from its impurities? So it has to undergo certain stages. So the first stage is, we are told that the copper ore, it is crushed, so they need to try to break it into smaller pieces. Then from there, this is now placed in a tank where there is some oil or some detergent. So during this stage of froth flotation, so this is what we call froth flotation. Then during this stage, some of the impurities like sand will be separated from the copper ore, then it will sink to the bottom, so they will settle here. Then the remaining copper ore will float to the top. So overall, what we are saying is the importance of this stage, or the importance of froth flotation, is to separate the copper minerals from the impurities such as silicon dioxide, or we can say such as sand. Now this stage does not get rid of sulfur and iron. This stage just gets rid of impurities, the unwanted materials such as silicon dioxide. So that is the picture for this question. Now we can write our answer, since we have some ideas. So we can write our answer. We'll say to separate the copper minerals from the impurities such as silicon dioxide. So this is the importance of this stage, the one we are calling as froth flotation. Now we can move on to question 2, Roman number 2. The copper ore is roasted in air. So whenever we have this condition of roasted, we are looking at this copper ore. Here we have now copper iron sulfide. So why do they roast copper ore in the air? So this one is just to remove impurities like remove impurities like iron, and also to convert the ore to oxide. So we'll say to remove impurities such as iron, and to convert the ore to oxide. So that is the importance for this stage, or for roasting copper ore in air. Question B now, write a balanced chemical equation for the reaction that occurs when copper ore is roasted in air. So this stage we have now copper sulfide. So roasted in here, we are saying we react copper sulfide with oxygen. So this now will remove the sulfide from copper, giving us copper plus C. Now the sulfur will react with oxygen, giving us sulfur dioxide. So this is the reaction that we are talking about. So from there, the chemical formula for copper sulfide is it's S2Cu2S plus C oxygen, diatomic, a gas. Then we have copper, Cu solid, plus we have sulfur dioxide, which is a gas. From there, let's check if the equation is balanced. We have 2 atoms of copper here, then 1 atom of copper here, so we need 2 in front of copper. Then let's check for oxygen. We have 2 atoms of oxygen, 2 atoms of oxygen, so oxygen is balanced. Then we have 1 atom of sulfur, 1 atom of sulfur, so our equation is now balanced. So this is the equation for roasting of copper. Then also the other importance of this stage, it is to remove sulfur from copper so that we can now have a pure metal copper. Now we can move on to question C. The physical properties of copper can be explained in terms of metallic bonding. So describe with the aid of a label diagram the metallic bonding in copper. So first, let's define metallic bonding. So metallic bonding is a type of bonding which involves the force of attraction between the cation or cations. The cations, we are looking at the positive charged ions, and the electrons in the metallic lattice structure. So let's see how we can draw this diagram. So this one, we just have to draw the positive. So we have the positive, then positive, positive, positive. Then from there we can indicate the negative. So this is how you draw the bonding in metallic bonding. So you just have to show the positive and the negative. Then here, the positive, these positive are known as cations. Then you say in a metallic lattice structure. Then for this electron, this is what we call sea of electrons. So it's where, like, we have a sea where we have a lot of electrons. So this force of attraction between the electrons, the sea of electrons, and the cations is what we call the metallic bonding. So now we move on to question C. Roman numeral number 2. Explain how metallic bonding makes copper to be malleable. So now, what is meant by malleable? So malleable is defined as the quality or characteristic of metals that says that a metal can be hammered into a new shape without breaking. So you can have a metal, then you hammer it into a shape that you want, like the way they form the holes, then also the axis. So that is the characteristics of malleable. So what makes the copper to have such kind of a characteristic? So you say metallic bonding. Metallic bonding makes the metals to be malleable to be malleable. If you remember, at the structure we said we have the positive ions and the negative ions. So now how can we connect with our answer? So we are saying it makes the metals to be malleable because the positive ions, so we can say because the positive ions are able to slide over each other, without breaking the bond. So that is what we are looking at. So that is the key. So even if you hammer it, the positive ions or the negative ions, they are going to slide. Maybe if we have something like this, this is the shape of the metal before you hammer it. Now let's assume now you hammer it here, then we are going to have a structure where this will bend like this. So what this means is this part here has moved this side, while this part here has remained here. So this part has been moved, has slid over this part here. Now question D, state one use of copper. So copper we can use to make electric cables. So that is the use of copper. Also to make cooking utensils. Some of the things we use in our kitchens are made of copper. So there are so many that we can, even hot water pipes, some of the pipes are made from copper. Okay, so now we move on to question 3, the last one. Nitric acid is an important acid in everyday life. Name the commercial process used to prepare nitric acid. So some of the preparation of these substances, such as the ammonia, nitric acid, oxygen, they have certain processes that they undergo. Now here our interest is, we are trying to mention the industrial preparation of nitric acid. So nitric acid is commercially prepared by the process known as Oswald process. So this is the name of the process by which nitric acid is produced. Now question B, state the catalyst used during the commercial preparation of nitric acid. Now the catalyst here is platinum. So platinum, rhodium. So this is the catalyst that is used during the process of Oswald process. Now for question C, where the question is all about, we need to balance this equation. So we have ammonia NH3 plus oxygen is equal to nitrogen monoxide plus water. So how can we balance? So we can see that nitrogen is okay. Now hydrogen is not okay. So let's look at the number. So if we, let's say we use 4 here, 4 nitrogen, then we also put 4 nitrogen here, so that we know here we have 4 nitrogen and also here we have 4 nitrogen. So now nitrogen is balanced. Let's look at hydrogen. If we multiply 4 times 3, we can see that we have 12 atoms of hydrogen. So we need a 6 in front of water, so that if we multiply 6 times 2, that is 12. Then let's look at oxygen. So oxygen, we can see that from this party there are 6 atoms of oxygen, then from this party there are 4 atoms of oxygen. So the total number of atoms of oxygen on the right side is 10. Then here we can just put a 5 here, so 5 times 2, then it's 10. So this is a balanced chemical equation. Now from there, let's move on to question D. The nitrogen monoxide produced as shown by the equation in C above react with oxygen to give nitrogen dioxide. So construct the balanced equation. So this is between nitrogen monoxide. So we have nitrogen monoxide. So that's with me, I like beginning with the first word equation. So we are saying nitrogen monoxide react with the oxygen. Then if these two react, what are we supposed to have? So we are told to give nitrogen dioxide. So our work now, let's just convert this. So nitrogen monoxide is NO, then gas plus oxygen gas, then we have nitrogen dioxide like this. So let's try to balance it. So we can see that here we have 3 atoms of oxygen, then here we only have 2. So let us try by, we put 2 here. We can see that we have 2 atoms of nitrogen, also 2 here, 2 atoms of nitrogen. Now this 2 is affecting the oxygen. So from nitrogen monoxide we can see that we have 2 atoms of oxygen plus these 2, we have 4. Then here we can see that if we multiply 2 times 2, we have 4. So our equation is now balanced. Now from there we can move on to question E. How is nitrogen dioxide converted into nitric acid in this process? So the final now of conversion nitrogen dioxide into nitric acid, so we'll say by reacting nitrogen dioxide with water. So with the water, so this is how it is done. Okay, now we move on to question F. Explain why the concentration of nitric acid cannot be made more than 68% even if it is distilled. So why do we have the maximum of 68%? Why not getting 100? So because here there is no drying agent. So there is no drying agent. When we look at the drying agent, there is no agent or substance that is getting rid of water. So even after we try, even if we try to distill it, we'll find that we are going to have water where the acid is. Now explain why the high concentration of nitric acid can only be obtained if it is mixed with concentrated sulfuric acid. Now, what is the importance of concentrated sulfuric acid? So it is a strong dehydrating agent. So it is a strong dehydrating. So dehydrating, we are looking at the removing of water. So dehydrating agent. So this is what the sulfuric acid is doing. So in this case now we are expected to have a high concentration of nitric acid, since some of this water being dehydrated by this sulfuric acid. Then the last one, give any 2 uses of nitric acid, so to make ammonium fertilizer. So ammonium fertilizer. Then number 2, to make plastics. So to make plastics. So this is how we can answer. So we are just saying these are some of the answers. I'm not saying these are the only answers, no. Some of the answers that we can answer, but if you research and you study more, you'd find that there are so many ways in which you can answer particular questions like this. Okay, so that's it for this video. Thanks for watching.